Hello students, in this lecture we will cover multiple linear regression and polynomial regression. So if you find this video helpful, please like it and subscribe to my channel. So let's start. Multiple linear regression is a machine learning technique or a machine learning algorithm that models the relationship between one numeric target variable and more than one predictor variables. It is called regression because the target variable is a numeric variable, and it is called multiple because there are more than one or multiple predictor variables. This is the generic equation of multiple linear regression, where y is the target variable, beta 0 is called the intercept, x1 to xn are the predictor variables or predictors, and beta 1 to beta n are the coefficients. Each predictor variable has a coefficient associated with it. For example, x1 has beta 1 associated with it, x2 has beta 2 associated with it, and so on. For example, we might want to predict the test score of a student based on two predictor variables: the number of hours the student studies and the number of hours the student spends on social media. Here, I have written an equation of such a multiple linear regression model. So in this equation, the student's test score is the target variable, the study hours and the social media hours are the predictor variables, 70 is the intercept, and 2 is the first coefficient, minus 5 is the second coefficient. The coefficients beta 1 and beta 2 explain the relationship between the predictor variables and the target variables. Let me show you how. Here, the value of beta 1 is positive. This means that increasing the corresponding predictor variable will increase y. Similarly, value of beta 2 is negative. That means that increasing this predictor variable will decrease y. So, x1 has a positive relationship with y, whereas x2 has negative relationship with y. So this, whether the relationship is positive or negative, is called the direction of the relationship. A second aspect is that the magnitude of beta 1 is 2, while the magnitude of beta 2 is 5. The magnitude of beta 2 is greater. This means that the impact of x2 on y is greater than the impact of x1 on y. That means that the strength of the relationship between y and x2 is greater than the strength of the relationship between y and x1. Sometimes the relationship between the predictor variable and the target variable is too complex for linear regression. Let me show you an example. Consider this data set from a laboratory that contains the growth rate of algae species at different temperatures. The lab researcher wants to build a model that can predict the growth rate from a given temperature. To solve that problem, I have plotted this data set on a plane where Temperature is the predictor variable plotted on the horizontal x-axis, and growth rate is the target variable plotted on the vertical y-axis. So, I have obtained a simple linear regression model from this dataset, and this is the equation of the simple linear regression model, and this is the regression line. But if we look at this regression line, it is not modeling the relationship well. There is a lot of distance between the line and the data points. Therefore, the line is not able to capture the relationship well. So we need a more complex model for such situation. Polynomial regression is such a model. Polynomial regression models the relationship between one numeric target variable and one predictor variable using an nth degree polynomial. This is the generic equation of polynomial regression, where y is the target variable, beta 0 is the intercept, beta 1 to beta n are the coefficients, and x is the predictor variable. So here in this equation, this is called the linear term, and this is called the quadratic term, and this is called the cubic term. We can choose the value of n according to our requirement. For example, if we choose the value of n is equal to 1, we will get the model till here, till the linear term, and we get this equation, which is the equation of simple linear regression. If we choose the value of n as n equals 2, we will get the model till here, till the quadratic term, and we get this equation. This is called the quadratic polynomial regression. And if we choose n equals 3, that is, we keep the equation till the cubic term, then we will get this equation, and this is called cubic polynomial regression. As we increase the value of n, the complexity of the model also increases. But in practice, it is common to take it till n is equal to 3. That is, to take it till cubic polynomial regression. Greater values of n will add unnecessary complexity. Back to the problem where we tried to use simple linear regression to predict the growth rate of algae given a specific temperature. I have plotted that data set here with temperature as the predictor variable on the x-axis and growth rate as a target variable on the y-axis. Further, I have obtained two models from this dataset. The green one is the simple linear regression model, and the red one is the quadratic polynomial regression model. Here the green line is the simple regression line, and the red one is the quadratic polynomial regression curve. It is evident from the plot that the quadratic regression curve is much closer to the data points than the green line. Therefore, we can recommend quadratic polynomial regression to the research scientist who wants to predict algae growth rate.